Okay, so now we want to make a genetic algorithm. So we'll do a function, call it next generation, and then we want to calculate the fitness. Then we'll do a crossover, and then we also want to mutate, for variety's sake, the child, and then we're gonna also have the new or the next gen start. So to do that, what we're going to do is we're going to make an array to store the players that have died. So I'm just going to copy this, and we'll make this saved players. And then when we remove a player, we'll then also add that player to the saved players array. So we'll just do saved players.add, and then we'll get this player. So players dot get I, not one, to get I. So now when a player is removed, it's also getting pushed into a new array. So in our genetic algorithm, the first thing we want to do is calculate the fitness. So we'll do void calc fit, and we'll do calc fit, and then this will be a void. So we'll go here, and then we'll start making our fitness function. So let me just clean that up. Okay, so for fitness, we will do a float sum, which will be set to 0. So now we want to select players exponentially, have them be better exponentially than or more likely to be chosen based on their score. So we're going to loop through the saved players. Do the size, and then okay, let's loop through them, and we'll say the score of each player will now be we're going to do math dot power, and then we'll do the score and set it to 2. Let's see, score is a integer, so let's make score a float, just to make it easier on ourselves. Okay, score, we'll set to this. Now math.power returns a double, so we'll just have to cast it back to a float to satisfy that. Now next thing we're going to do, just going to grab this for loop. We're going to basically sum all the scores of the players. So we're going to do score, and then plus equal that score. And then finally, to get the fitness, we'll do fitness will then equal your score divided by that sum. So now we calculated the fitness. We have it exponentially better, which will increase the chances to be chosen. Then we get the sum and we calculate the fitness. So that is done. So now let's look at crossover. Now I'm going to use code here by Daniel Schiffman from the Coding Train. I'll link to his video series that he did in P5.js, but basically this is to select a candidate. Now, when he did it, he's only basically adding one player back into the next gen, which is fine, it works. But I've always wanted to play around with crossover. So I had a look. If you look in the neural network, there's basically 4 values that you can play around with. And these 4 values are input weights, hidden out weights, the biases of H, and O bias. So basically, it's this code. Now there's one more thing we want to do just before we continue. Let's go back to player, and then in player we want to do a mutate function. So we'll get the brain and we'll mutate the brain by some number. And okay, we'll go back to our genetic algorithm. So pause the video here, get the code. This will basically be one parent, and then we'll do a crossover from there. So okay, let's do our crossover, which will return a player. So let's do crossover, and it takes in a player, let's call it parent A, and then another player, let's call it parent B. So let's have another player, we'll call this child, and then let's set it to parent A, basically. So now if we go to our neural network, we'll grab the first one, and then let me just format that. Okay, so this is our input weights. So we don't need to calculate any values here. We also don't need to mutate them. Whoops. But what we want to do is we want to get the child and we want to get the brain, and then have its input hidden weights and values then be set to either parent A or parent B. Now the child is already parent A, so what we'll do is we'll say we'll get a random number between 0 and 100. So this will be literally 50-50 percentage. So we're going to round this down or up to the nearest integer, and then we'll say if it's larger than 50, then we'll get the child's weights, and then we'll say, okay, we've got the brain, now we need to set it to parent B. So we're going to copy this and then copy parent B. So every time the child's input weights values greater than 50, it will be set to parent B. So now let's just copy this and let's get the next one, which is the HO. So we'll do this 4 times, copy this, and then get the next one, which is the H bias. Copy this over 4 times, and we'll get the last one, which is the O bias, and then copy this over 4 times. And then finally, we'll just say child dot mutate, and then we're going to return this child. So now we've done some sort of crossover. Is it more effective than just simply selecting a single candidate? I don't know. It worked for me, so I'm using it here. If you don't want to use it, you can just add this candidate into your next generation. Okay, so now we've got crossover. What we want to do is grab the crossover function, and we're going to add this into the population. So let's say for int I equals 0, I is smaller than, let's get our total players, I++. Then we'll get our players dot get I, no, sorry, just add. Simply just add it in. So we'll get our crossover function, and then we'll get a candidate, and then this will be parent A, this will be parent B, and now we have done crossover, we've done mutation in the crossover function. So what we're going to do now is basically just clear this save players code. So I'll say save players.clear, and then what we also need to do is we want to clear the enemies. So enemies.clear. So in the next loop it will be random again. Then we want to do what we did here in setup and just push in a new enemy, and then we'll just also set the enemy speed back to say 10, and we'll do a frame count and have that go back to 0. So let's just do int gen, which will then also count the generations for us. So we'll say gen++. So to see if this is working, what's wrong? Can I find name player? Okay, of course it's players.add. Let's see. It cannot be resolved. Oh, okay, because we need prints a brain.length. We cannot directly access this, so we just need one of the brains. It shouldn't matter which one, because then inputs and outputs are the same length for all. Okay, so here we go, and they're all dead. And I'm not seeing any new players being added, so let's see. Oh, because we aren't actually calling that function, so we need to be calling the next generation function. Okay, so there they go, and they're dead, and next generation, and one made it, and that's basically it. That is literally it. Now you can tweak this, of course. We can make it easier, for example, so let the enemy only have a width of, for example, 50. Then what we also can do is we can up the total player count, which should help a bit. And then you can also, of course, have them start later. So make it a bit easier, and you can see they're already improving. And this guy is a champ. So this guy probably will go on forever, and there's a reason for that. And that is because the enemy speed never changes. So this guy is ideal for this situation. He will never die. So let's just make it a bit harder for the players. So let's just say, let's take this frame count. If this frame count modulus 1000 equals 0, so every 1000 frames, what do we want to do? So we're going to take the enemy speed, and we're going to do times equals by some amount, maybe this. So every 1000 frames, the speed will increase. So let's have them go. And these two are champs again. One made it. Enemy speed times not 1.05. So slightly increasing the enemy speed every 1000 frames. Okay, but this is basically done. And now there's one last thing you could do. Let me just have a look. There is a nice little library for P5 that emulates the P5 slider, which I quite like. So I'm just gonna drag in that library. So now I'm gonna open up the template. This is basically just a template I wrote to actually implement it. So we need to import library, and then let's say 20 here, and then we'll also create a slider. So you can see the library is called Control P5, and we'll say 20, and we'll start it at 1. You can copy this code down, pause the video. Okay, so what you can do now to not wait forever when you're training your neural network is you can have an outer loop where we say slider and then U++. So where am I? How do I get there? Okay, anyway, so we'll just go down here, format this, and hopefully I didn't mess anything up. Of course, JavaScript brain. So let's just make this 1. So it starts from 1 to 20, and then you set the value where you want it. So they're playing, and then you can speed it up so you don't have to wait forever. So, but this guy again seems like a champ. It's going to take a while probably for him to die. But yeah, that's it. I'll do more complex ones soon. Yeah, bye.